So this is our today's chapter, current electricity. In this portion, the first portion of the chapter is very much common in class 9. We study about the charge, current and resistance. First portion is called charge. It's the most important thing you have to know when you are going to study this. We all know that each and every atom is made up of three basic particles: electron, proton and neutron. Out of this neutron and proton stays in the nucleus and the electrons move in circular orbits, right? This is where from we got the idea of charge. But in physics, the first idea of charge occurred when we studied the chapter of static electricity in class 8, when two objects were rubbed with each other and we found out that two things are getting the opposite kind of charges. Exactly, yes, there is nothing like positive charge or nothing like negative charge. Basically, there are two opposite kind of charges in nature, which we call one positive and the other one is negative. If somebody names it as A and B, it will just be same, because the electron's charge does not carry any significant characteristics which we can use to call it negative, or nothing special for proton. They are just opposite to each other. Keep this basic concept very clear. Now we all know that the charge, that is the we call positive charge, that stays in the proton, stays inside the nucleus and it never comes out because of the strong nuclear force. But who comes out is electron. These electrons basically is the main reason behind all kinds of charges flow in nature. These electrons, when they comes out of the atomic structure, they are called free electrons. And these free electrons are the main reason behind all kinds of current flow. So we got charges basically of two kinds: positive, negative. Clear? I think these things are already done in class 9. Still I'm giving a revision. Now the next part is current. Current in definition is known as rate of flow of charge. What do you mean by rate of flow of charge? Rate of anything means how much that thing is happening per unit time. Means if I am talking about rate of flow of charge, that means how much amount of charge is flowing in unit time. So just like if I tell you in 10 seconds 40 coulomb of charge flows, yeah, I missed a point. Coulomb is the unit, the SI unit of charge is coulomb, in short C. Clear? Now we must need to remember that how much charges are flowing per unit time. This, for example, you consider that 50 coulomb of charge is flowing in 10 seconds. So what is the current flow? The current flow means rate of flow of current, means how much current is flowing in 1 second. So in 10 seconds 50 coulomb. So in 1 second 50 by 10, that is 5. So what did we just do now? Just divided the charge, total charge, by total time, right? So this division, this charge by time division, gives you the current flow, and that is also the mathematical formula. Current flow is charge by time. Clear? Q by T, and the symbol of current is I. So the final form is I equals to Q by T. I equals to Q by T. Now the next important thing, this is the mathematical form of current flow. Can be also asked, what is the unit of it? Always we follow the SI unit patterns. It's coulomb per second. Coulomb per second, that is charge by time. So coulomb per second can be used as its unit, but this coulomb per second is named after scientist Ampere, and so the SI unit of current flow is called ampere A. The smaller versions are milliampere, where 1 milliampere is 10 to the power minus 3 ampere, microampere, which is 10 to the power minus 6 ampere, and so on. Nanoampere, picoamperes are also available, but not so much useful. Clear? This is our next topic. Now, what is the definition of current flow? Is understood. It can be also asked, define 1 ampere. What do you mean by 1 ampere current flow? It's a tactically asked question, so you can ask this very easily with some numerical values, that if 1 coulomb of charge flows in a circuit in 1 second. So if 1 coulomb of charge flows in a circuit in 1 second, the amount of current flowing is called 1 ampere. The amount of current flow is called 1 ampere. Clear? The next topic we can move forward is the electronic description of current flow. The electronic description of current flow means you're just calculating the charge by time as current. If I just ask you how many numbers of electrons moved just now, it's quite easy. We all know the charge of one single electron. What is the charge of one single electron? One electron is 1.6, more precisely 1.602, 1.6 into 10 to the power minus coulomb charge. That is the charge of one electron. That means the flow of one electron means this amount of charge is moving. Now all these charges are basically multiples of electronic charges. Means if 1 ampere current is flowing, there might be 100 billions of electrons are flowing. So all kinds of charges can be represented by some multiplication factor of electrons, where E is the one electron's charge and N is the number of electrons flowing. So if I multiply these two, it gives me the total charge flowing in the circuit. So Q equals to Ne, where N is the number of electrons and E, we know the charge of one electron. So as Q equals to Ne, so current flow I equals to Q by T. Just got it before. If I put the value Q equals to Ne, I get I equals to Ne by T. Understood? I hope this is clear. After we finish these two portions, we move to the third portion, which is called potential. I want to be very much specific to you that in problems we basically calculate potential difference, not potential. And potential difference are basically two different quantities. The first question appears, what do you mean by potential? Clear? Now the answer is very simple. If you bring 1 coulomb of charge, 1 coulomb of charge is brought from infinite distance to a point on field, So 1 coulomb of charge, this is very much important, is brought from infinite distance to a point on field. You know, just like any other things, the charge is also having some amount of mass. Even an electron is having very small amount of mass. The mass of an electron is roughly 9.11 into 10 to the power minus 31 kilograms. This is the mass of a single electron. Okay, now if any object which is having mass is moved from its position by some distance, we need to apply some force, and if we apply force, some displacement occurs. Force multiplied by distance gives me work done. So similarly, if I bring 1 coulomb of charge from infinite distance to a point on field, I have to do some amount of work, and that amount of work which is done to bring 1 coulomb of charge is called its potential. It is represented by V. Clear? Represented by V. So what is the definition of potential? The definition of potential is that the amount of work we have to do to bring 1 coulomb charge from infinite distance to a point on the field is called its potential. So just like if I bring q coulomb of charge, and to bring q coulomb of charge I have to do w amount of work. So just see that to bring q coulomb of charge I have done w amount of work. If I have to calculate the potential, I need to calculate the work done to bring 1 coulomb of charge. Then work done to bring 1 coulomb of charge is w divided by q, and this gives me work done to bring 1 coulomb of charge. So this is basically potential. That is why the formula of potential is V equals to W by Q, where V represents the potential, W represents the work done, and Q represents the charge. Now this is all about potential, but potential and potential difference are two different quantities. So now we will learn what is potential difference. In most of the mathematics we will calculate potential difference, not potential. I repeat once again. Fine. Now see here that in a field there might be 2 points, point A and point B. Clear? The potential of the point A might be VA and the potential of the point B is VB. Clear? So the difference in potential is VA minus VB. Difference in potential V equals to VA minus VB. I am just taking VA is greater, so VA is forward. So VA minus VB gives us the potential difference. Now this thing is calculated like, if I have a charge of 1 coulomb here, if I have to bring this charge to point B, so to bring 1 coulomb of charge, how much work I have to do for bringing it from point A to point B, that thing is also called potential difference. So if I have to do W amount of work to bring 1 coulomb charge from point A to point B, this W will give me the potential, this W amount of work if I have to do to bring q coulomb of charge, then W by Q gives me the potential, and this gives me the potential difference, that is VA minus VB. So VA minus VB is actually W by Q also in case of potential difference. Means VA minus VB tells us how much work we have to do to bring charge from point A to point B. So W by Q, work done per unit charge to bring 1 coulomb charge from point A to point B on the field, and that thing is called the potential difference between these 2 points. And in most of the numericals we will determine the potential difference, not the potential. Remember. Now coming to the important thing, units. We all know the unit of potential is volt. Full name voltage, volt expressed by V. What is this volt basically? Now V equals to W by Q. You calculate potential difference, that is W by Q. You calculate potential, that is also W by Q. So in any way the formula is W by Q. That means what? Work done per charge. Clear? So unit of work is joule and unit of charge is coulomb. So volt is basically joule per coulomb. Understood? So if I ask you what is 1 volt, 1 volt is 1 joule per coulomb. This can be asked to you. What do you mean by 1 volt? 1 volt potential difference. What should be the answer? The answer is that if between 2 points I have to do 1 joule of work to bring 1 coulomb of charge. To 1 joule of work to bring 1 coulomb of charge, then the potential difference will be 1 volt. Remember, this is how you define 1 volt. So we got 3 quantities in our knowledge: potential difference, V, current I, and charge, that is Q. These 3 things we have understood so far. So this is the ending of the first lecture. This much you have learned already in class 9. We have just recapitulated and understood little bit of details. I hope all of you got this. Thank you.